In this video, we're going to continue to talk about properties of rational exponents. When you have nth root of x to the n, this will equal to x only if n is odd. And let me give you some examples. Let's say you have cube root of 5 to the third. This will be same thing as 5 because x is 5. Also, when you have cube root of quantity -5 to the third. Now you got to be careful here. What is x? X is -5. And also you have 3 -5s. So when you take out, it will be -5. Now, nth root of x to the n power will be absolute value of x if n is now even. Let's say you have fourth root of quantity 2 to the fourth power. What is that? That's going to be absolute value of 2, which is 2. But if you have fourth root of quantity -2 to the fourth power, it's not -2, because if you think about it, there are 4 negatives, and when you multiply 4 negatives, it will be positive. So actually this is absolute value of -2, which will be 2. So be careful with exponents. See if the n is even or odd. Let's take a look at this example. You got cube root of 27d to the 12th power. Well, you could rewrite the radicand as 3 to the third power, and it's d to the fourth to the third power. And since this is a 3 to the third power and d to the fourth to the third power, you can rewrite it as 3d to the fourth, that whole thing to the third power. Now notice, this is 3 and that's 3. So n is 3, which means that this will be same thing as 3d to the fourth. You could also think of it as there are 3 of d to the 3d to the fourth power. So 3d to the 4 comes out. So that will be your answer. Let's take a look at the next example. You got fourth root of x to the fourth over y to the 16th power. So this will be same thing as fourth root of x to the fourth over fourth root of y to the 4, that whole thing to the fourth power. So now our n is even. So this will be equivalent to absolute value of x, since n is even, over absolute value of y to the 4th. Now, if you think about it, anything to the power of 4, even power, will be positive. So we don't really need absolute value over here. So it will be absolute value of x over y to the 4th. Now, when we assume all variables are positive, we no longer have to worry about absolute value because all variables are positive. So you got cube root of 2a to the 13th, b to the 3rd, c to the 8th. Now you need 3 of the same kind. Since index is 3, you need 3 of the same kind to take it out. So 2 is by itself. What about a to the 13th? We could rewrite it as a to the 4 a to the 4, a to the 4, and a. Notice, when you multiply these, you'll get a to the 13. What about b cubed? That's just b times b times b. Now what about c to the 8? That's c squared, c squared, c squared, c squared. So we need 3 of the same kind. A to the 4th comes out, b comes out, c squared comes out. And what stays inside? So this came out. Let's cross that out. You got 2a and c squared. So that will be our final answer. Again, we don't have to worry about absolute value because all variables are positive. Now you got x squared over cube root of y to the 13. So if you want to simplify it, you got x squared on top. I'm going to rewrite y to the 13th as y cubed times y cubed times y cubed times, sorry, I need to write it as y to the 4th. Y to the 4th, y to the 4th, y to the 4th times y. So when you multiply this out, you get y to the 13th. Now, so you end up getting x squared over y to the 4th comes out, cube root of y. But remember, we're not supposed to have radical on the bottom. So how can we take out this y? Well, since index is 3, we need 2 more y's. So you need to multiply cube root of y squared, both top and bottom. So what do you get? You get x squared cube root of y squared all over. Now, cube root of y times cube root of y squared will be y. So y comes out, and y times y to the 4th will be y to the 5th. So this will be your final answer. We need to simplify this, assuming all variables are positive. So for this example, what I like to do is, I like to make negative exponents to positive. And I only see one negative exponent here on the bottom. So if you want to make that into a positive exponent, you need to move z to the negative 4 to the top. For example, if you had a negative exponent on the top, if you want to make it into a positive, you got to bring it to the bottom. So you get 16x y to the 3rd, z to the 4th over 8x to the 2/3, and that's it. Now all we need to do is simplify. 16 divided by 8 is 2. When you divide a variable, you have to subtract exponent. There's 1 here. So 1 minus 2/3 is 1/3. Y to the 1/3. And you got z to the 4th. So that will be your final answer. Now you're adding the radicals that has a radicand that are variables. So you got cube root of x and you got cube root of x. All we need to do here is add the coefficient. You get 8 cube root of x. So for this example, we have a same index, but we have a different radicand. So we need to make these two, we need to make it so that these two have the same radicand, and then we could subtract. You have p to the 6, so p could come out. When p comes out, you have a 3p squared inside the radical. What over here? P squared cannot come out, but 24, you could break it down. So you have 3 2's, 2 comes out, and 3 has to stay inside, and p squared has to stay inside. So now you have the same radicand. You subtract, you get 14 p, fourth root of 3p squared. And that'll be your final answer.